This is the first video in a series we are dedicating to a thorough introduction of MistAway's equipment. We're going to start by reviewing the components that make up the nozzle circuit. The primary components fall into three groups: the nozzles, tubing, and push-to-connect fittings, and we'll talk about each. Let's start with the nozzles. This is what we refer to as a slimline nozzle. You'll see that it is small and sleek with a low profile. After all, the goal is to install an effective system that essentially disappears into the backyard and landscaping. MistAway slimline nozzles come in two basic geometries. One has a straight adapter, the other has an adapter with a 45-degree bend. Both nozzles have the same tip. The adapters are nickel-plated brass, and the tips are made from 316 stainless steel. Both will resist corrosion, although in the saltiest coastal environments, rust will form on the tips over time, and they will need to be replaced. You can disassemble the nozzle easily by unscrewing the tip from the adapter. And you can disassemble the tip itself by unscrewing the plate that has the nozzle orifice from the body of the tip. You can remove the components inside by tapping the body of the tip against a hard surface. Here's what you'll find, starting with the upstream components and moving toward the orifice. A ball and spring combination, which acts as a valve, opening the nozzle when it reaches a certain pressure, and allowing the nozzle to close when the pressure falls below that level. A filter to catch contaminants before they can plug the orifice. A vortex pin, which gives a conical shape to the mist, and the nozzle tip, which contains an orifice with a diameter of 12/1000ths of an inch. As the nozzle tips are in service for a while, they'll eventually get fouled with gunk. You can purchase replacement ball and springs and filters to rebuild the nozzles, and they'll act just like new. Next, let's briefly touch on the tubing, the connective tissue of the nozzle circuit. MistAway carries three colors of 1/4-inch tubing: black, white, and tan. The tubing is extruded from nylon, and we use it because it is the most cost-effective solution that meets the flow and pressure requirements of the systems. From a durability standpoint, the nylon stands up well to sunlight and seasonal temperature swings without wilting, sagging, or cracking. And together with the push-to-connect fittings, it is quite easy to work with. Now let's talk about the fittings, which allow you to connect everything together. There are three primary 1/4-inch push-to-connect fittings you'll use in installing a nozzle circuit. They are also made from nickel-coated brass. By far, the most commonly used of these three is the 1/4-inch Union T. T's have two main uses. They are used to position a nozzle in a tubing run. Here the nozzle fits into the leg of the T and the tubing is inserted into either end. T's are also used to create a run of nozzles that branches from the main run. Next, there's the 1/4-inch 90-degree Union elbow. The elbow looks just as it sounds with two ports. The elbow can either be used to connect the last nozzle on a run, or more commonly, to enable the nozzle circuit to cleanly turn a corner. Say, for example, around an eave. Using a Union elbow in the run enables you to make a 90-degree turn in the nozzle circuit and ensures that you don't kink the tubing and impede the flow of solution through it. Finally, we have the 1/4-inch Union coupling. The Union couplings also have two uses. They can connect two pieces of tubing, say in the repair of a leak, where you can replace a short segment of tubing that has been cut without replacing the entire segment. And they are also used in a special kind of nozzle assembly called a riser, which we'll talk about shortly. But first, let's talk about working with these simple components. Look more closely at one of the fittings. As we've mentioned, MistAway's fittings are push-to-connect. In contrast to what are called compression fittings, they are very easy to work with and don't require use of a wrench. Inside the port on the fitting, there is an O-ring that creates a seal around the tubing or nozzle stem. If you take a close look at a nozzle adapter, you'll see the stem has a groove machined into it. When this stem is pushed into the fitting, the O-ring makes a seal above the groove. You can feel a satisfying click when this happens. Also inside the fitting, between the opening and the O-ring, is what is called a collet. The collets are sleeves that have a cylindrical inner surface and a conical outer surface. This is what a collet looks like when it is removed from the fitting. Its primary function is to form a collar around the tubing and exert a strong clamping force. The teeth on the collet actually bite into the tubing and keep the tubing securely in the fitting. To use the fittings, insert the tubing into the opening until it is pushed in as far as it can go. Then, just to be sure it is secure, push it in just a little more and pull back on it. Doing this should ensure you have a good seal. A key factor in getting a good seal is to make sure you have a clean, straight, perpendicular cut on the tubing. You make that clean cut with a tube cutter, like this one. Now let's talk about landscape risers. Risers are nozzle assemblies that are installed, most typically in landscaping beds. They keep the mist low and on property, and they are effective in flushing insects from their harbors in the surrounding landscape. The tubing on either side of the riser is usually buried in a shallow trench. The riser assemblies are available in short 15-inch and long 30-inch sizes. The risers themselves are made of 1/4-inch copper and have a notch machined onto both ends so they will seat and seal with the associated fittings. Let's take a look at a complete riser assembly which is made up of 5 components: the copper riser, the stabilizer stake, a union T on the ground end, a union coupling at the top of the riser, and typically a 45-degree slimline nozzle. Note that there are 2 notches cut out of the stabilizer, each size to accommodate a union T. Usually the tubing to and from the riser will be buried, and for this you'll place the T into the bottom notch. If your tubing will not be buried, you can use the top notch. Slide the union T into one of the notches, then slide the copper riser into that fitting and lock it into place. Next, use a union coupling and slide it onto the top part of the machined riser and lock it into place. Then complete the riser assembly by inserting a 45-degree slimline nozzle into the union coupling. Before we end our review, let's briefly touch on a few other components: the inline filter, 3/8-inch fittings, and what are known as 40-23 nozzles. We strongly recommend you use an inline filter like this one in your nozzle circuits. It is spliced into the 1/4-inch tubing just downstream of the unit. If foreign matter manages to make its way through the intake filter on the pump, this filter can trap it before it can find its way to a nozzle and plug it up. As you can see, the filter is about 3 inches long and has 1/4-inch push-to-connect ports to splice it in line. Make sure the upstream line is plugged into the port labeled in. You can remove and either clean or replace the sintered bronze element in the filter. As we discussed in the pressure drop videos, a large nozzle circuit might require the use of 3/8-inch tubing as a pressure boost to manage around pressure drop in long runs. In order to use this tubing, you'll need 3/8-inch union couplings and sometimes union Ts. To tie into the 1/4-inch tubing, you'll also need what is called a 3/8 to 1/4-inch reducer fitting, which looks like this. 1/4-inch tubing fits into one side of the reducer. The other side fits into a 3/8-inch union T or coupling. The booster line would tie into the 1/4-inch line in an assembly that looks something like this. And finally, at some point, you may run into some misting nozzles that look like this. They are the generation of nozzles formerly used in mosquito misting, prior to slimline nozzles, and we mention them only because you may encounter them in the field or see them in photos. They are known as 40-23 or Hago nozzles, and their primary application is to atomize oil in fuel oil burners. In misting systems, they are almost identical to slimlines with respect to flow rate and droplet size. Over time, they have become less used than slimlines due to their cost and size. If you find yourself in a position where you need to replace a tip, you have 2 options. You can either buy a replacement tip, like the one shown here, or you can convert the fitting for use with a slimline tip with this converter. That's all for our review of the nozzle circuit components. In the following videos of the series, we're going to dive into the design and functionality of our misting units.